Garg, working as a lecturer in C department at PSBTE&IT, Leragaga. Today I am here to present my lecture on the topic, that is basic input output system. The system which starts your system. The basic input output system is a BIOS system that gives the starting to your system, that gives the power to your system, that gives the control of the computer system to the operating system. These are the various contents that I will cover through my lecture. First of all, the bridge introduction, that is how all the components of the computer are connected with each other, how they can communicate with each other. That is the purpose of the BIOS. The bridge is just a physical connection between all the components of the computer system, between the CPU and the memory, and between CPU and video and many more other devices can be connected with the bridge only physically, but how they can communicate, that is the purpose of the BIOS only. Then why this booting is required? The BIOS also helps in booting, that is the control of the control of the system will be handed over to the operating system, that is known as booting. So, why this booting is required, that I will cover. What is this booting process all, then the functions of BIOS, then after that how the BIOS can be configured, various configuration settings I will tell you. Then BIOS versus CMOS, complementary metallic side semiconductor chip. The BIOS program can be stored in two ways, that is on the ROM memory, that is the permanent memory, and the second can be stored on the CMOS chip. So, the distinguish among various CMOS setup utility options, how the CMOS setting can be changed. Then what are the interrupts and how they can handled, that I will cover. What kind of interrupts can be there in your system, and what are the methods of data transfer that can be followed within your system between the CPU and the IO devices. Then what is the difference between the interrupts and the procedures, because the interrupts are handled by the interrupt service routines, that are again the procedures for handling the interrupts. Then the BIOS services, various BIOS services that are provided by your BIOS system. The very first, this is the historical, or we can say conceptual view of our modern computer system. There are various IO devices, the various processing unit is there, the speakers, IO devices, keyboards, monitors, printer, mouse, various components are there. How these components can communicate with each other? If there is no connection between these components, can they communicate? This is just a bare hardware machine. They cannot, if they cannot communicate, nothing output will be come out of this system. So, the data flow through the computer between the CPU and the RAM, between the CPU and the video, and between CPU and various other devices. The CPU need to communicate with all other devices for the data flow through the computer. So, there must be some connecting devices that can interconnect between the CPU and all the other devices. The bridges are those devices which are used to connect the various pieces, I can say various components to the CPU. Now, there are two kinds of bridges according to their location, according to their distance from the CPU. The first one is called north bridge, that is the bridge closest to the CPU. The second bridge is the south bridge, that is the bridge farther from the CPU. The first bridge, north bridge, is used to connect the CPU to the video and the memory. Video and or memory. North bridge is a chip, or we can say set of chips that connect the CPU to the video and or the memory. And the south bridge handles all kinds of inputs and output to the many devices in your system. So, chipset, a chipset is a set of north bridge as well as south bridge chips that work together, that communicate together. This is the diagrammatical view of your north bridge and south bridge. The north and south bridge have connectivity with all the devices in your system. The address bus is connected to the south bridge, external data bus is connected to your bridges, the input devices, storage devices and output devices all are connected to the CPU by a south bridge. There is a RAM which is connected directly to the CPU by a north bridge. This is the chipset, how this is this covers all the connections with the CPU between the various IO devices, various memory devices, and your RAM and graphics cards etc. are connected to the CPU by a north and south bridge. So, the BIOS, what is the BIOS? The bridges connect the devices, only physical connection is there between the devices, but without a program, but without a program they do not know how they can communicate, without a program this is not possible. So, we need a special kind of program that is required to enable the CPU to talk to other devices, because for any kind of performance, for any kind of output, we need the CPU to talk to other devices. Communication is must for any kind of performance. So, for that kind of communication, a special program is required that is known as BIOS. These programs are collectively known as basic input output service, that is the BIOS. A flash ROM chip stores all these programs. A flash ROM chip. ROM is the permanent storage, that is read only memory that cannot be changed. Nowadays the data can be changed, data can be reprogrammed by so these ROM chips are known as flash ROM chips. In this diagram, the keyboard talks to the external data bus. We can say this, the keyboard talks to the external data bus through this chip controller, through this keyboard controller. This is one kind of chip, that the number is 8042. This is a keyboard controller. So, the keyboard talks to the external data bus, communicate with this external data bus through this chip controller, keyboard controller. The question is now, how can the CPU get data from this 8042 chip? For example, keyboard controller chip say, how can the CPU get the data? Each program here we can call as a service. Programs stored on the flash ROM chips are known as firmware, and the programs stored on the erasable media are called as software. So, the ROM chip, this is the ROM chip. This ROM chip stores a program. The ROM chip consists of a program that enables a CPU, that enables this CPU to communicate with this controller chip. This is built into the motherboard itself. So, the BIOS program जो है that is enabled, that enables the CPU to talk to this, to communicate to this keyboard controller chip. So, that's how the keyboard can input its character to the CPU. Keyboard can input its character to the CPU by this controller chip, and CPU can talk to this controller chip, keyboard controller chip, through this ROM chip program, that is BIOS program. So, this BIOS, what is BIOS? This is the basic input output system. This boots the computer by providing a basic set of instructions. This loads the operating system after turning on the computer. Then it performs the post, that is power on self test. In the power on self test, all the devices, all the peripherals connected to the computer system are checked for their functionality. Then it provides a setup program for changing the BIOS parameters. The various BIOS parameters can be changed as per our requirement. Provide the low level routines for communication between the operating system and the hardware. What are the advantages of storing this BIOS on ROM? Why we choose only ROM for storing this BIOS? The reasons are, code and data are readily available during booting. Whenever a booting is there, whenever your system boots up, the code and data are readily available at that time. Secondly, the BIOS content are not corrupted by any kind of errant applications, and no virus infections are there. That is why we use ROM for storing the BIOS. The various BIOS hardware components are, first is BIOS ROM. It stores the program startup program, that is your power on self test checking program. Then a second hardware component, that is BIOS CMOS memory, that is complementary metal oxide semiconductor memory. It houses the configuration information of individual PC. It consists of all the configuration information regarding every PC, what is the timing, what are the memory requirements, etc. Then the BIOS ROM. and BIOS CMOS memory. What are these? All the BIOS are contained in ROM in the old days, but nowadays BIOS is located in EEPROM chip. This is electrically erasable PROM chip, electrically erasable programmable ROM memory chip that is erased and rewritten by special programs. That is why this is called flash BIOS. And CMOS memory provides a non-volatile storage for PC's control information, need very little power to operate, and it is powered by lithium battery, one kind of battery that this provides the power to the CMOS memory. Introduction to BIOS. This is the chip diagram that is present in every system, ROM BIOS, that is. The power supply boot process, the BIOS boot process, what are the various steps that undergo through the boot process. The power supply, first of all we switch on our PC system, that is power supply sends the signal to the components in the system unit. The CPU finds the ROM chips that contains the BIOS. The BIOS perform then post, that is power on self test, which checks the component, example your mouse, keyboard connectors, expansion cards, etc. for their functionality. The results of the post are compared with the data that is stored in the CMOS chip. The BIOS looks for the system files in the floppy disk drive or the hard disk. The system files and the kernel of the operating system load into RAM from hard disk. The control of the system will be handed over to the kernel of the operating system, that is loaded into the first loaded into the hard disk, and that is transferred to RAM after that. Then during the boot process we can receive some beep codes. We can receive some beep codes. The various kinds of beep codes can be there, the different meanings according to that. We can judge the system performance, we can check the system according to that. If there is a one long beep followed by 3 short beeps, then this means your video is determined to be missing or faulty. If the system is okay, everything is okay, checks out, then there will be 1 or 2 short beeps will be there. If the RAM is missing or faulty, RAM is not working, then buzzing noise continuously, there will be a beep noise that repeats until your power is turned off. Then more complicated beep codes can be there. For those beep codes we can check our motherboard manual, which is available with the system. Then during the post checking, power on self test checking, there various kinds of error messages are there. They are shown on the display screen, and we can interpret those error messages by consulting our owner manual. So why this booting is required? We are saying that booting process is there. Why this booting is required? Hardware, as the hardware don't know where the operating system resides in memory and how to load it. As the hardware machine don't know where the operating system resides and how it can load it into the main memory. So we need a special program to do this job, that is bootstrap loader. For example, our BIOS basic input output system. This bootstrap loader locates the kernel and loads it into main memory and then starts with its execution. What it does, bootstrap loader locates the kernel from the wherever it is stored into the hard disk and loads it into the main memory and starts with its execution. But in some systems, a simple bootstrap loader fetches a more complex boot program from disk, which in turn again loads the kernel. This is the BIOS interaction with each and every component on the with the motherboard, controllers on the motherboard, controllers of the peripheral cards, with the various drivers, with the various applications, and directly with the operating system it can communicate. This is the BIOS interaction with all the other chips, with all the controller cards. These are the various tasks which are performed at boot up. It will run the diagnostics to determine the state of the machine, in which state the machine is. It will be determined after this diagnostics. If the diagnostics pass, only then the booting continues, otherwise your machine will give some beep messages. then it will run a power on self test to check the devices that are connected with the computer, that the computer will rely on for its functioning, are functioning or not properly. Then the BIOS goes through a pre-configured list of devices until it finds one that is bootable. Then the BIOS starts it searching for one of the devices that is bootable, so that it can boot its operating system from there. If it finds no such device, there may be a chance, if it finds no such device, an error is given and the boot process stops. I have mentioned here in the diagram, it will start from this CD-ROM device. It will start searching for its bootable device. If it finds no such device, there will be an error message, disk boot failure. Insert disk system disk and then press enter. This is the error message if it finds no boot device during its boot procedure. Then it initializes the CPU registers, device controllers and the contents of the main memory. After this it loads the operating system. At last the operating system will take over the charge of the whole computer system. It acts as the manager of all the devices, it acts as the manager of all the processes, it acts as all the memory system is managed by this operating system. Means the overall controller of the system will be then operating system only. फर्स्ट जब तक आपका सिस्टम स्टार्ट नहीं हो जाता, बूट नहीं हो जाता, ऑपरेटिंग सिस्टम के हाथ में उसका कंट्रोल नहीं आता, तब तक आपकी ये जितना भी ये स्टार्टिंग प्रोसीजर है दैट इज हैंडल्ड बाय दिस बायस मेमोरी. देन this is again the next task that is performed at the boot up procedure. On finding a bootable device, the BIOS loads and executes its boot sector. Whenever it finds a bootable device, whether that is a hard disk, whether that is your CD, from CD you can boot your system. Whenever it finds a bootable device, the BIOS loads and executes its boot sector. In case of hard drive, this is referred as the master boot record, and it's not often not operating system specific. The master boot record code checks the partition table for an active partition. It will find an active partition in which the operating system is loaded. If one is found, the MBR code, the master boot record code, loads that partition's boot sector and executes it. And the boot sector is often this boot sector is often operating system specific. However, in most operating system, its main function is to load and execute a kernel which continues startup. In most of the operating systems, its main function, जो boot sector है आपका, its main function is to load and execute a kernel which continues your startup. उसके बाद kernel जो है that will take the charge of the system in its hand. If there are no active partitions, sometimes we have not created our partitions. If there are no active partitions or the active partitions boot sector may be invalid, there are chances the active boot partition is there but its boot sector is not in working, it's invalid state. Then the master boot record, what it will do? It may load a secondary bootloader. It may load a secondary bootloader and passes the control to it, and this secondary bootloader will select a partition, often by a user input. After that, the selection of the partition is dependent on the user input. The user will be asked to enter the input to which partition the user want to enter, as there is no active partition or the active partition's boot sector is not valid, and load its boot sector. There are various examples of secondary bootloaders, that is your grub is there, a grand unified bootloader, then the last is, next is Linux loader, the last is NTLDR, that is NT loader. This is the Windows screen I have drawn here, taken here. This is the grub version 8.98, 0.98. This is what this is showing. There is no active partition. from this the list of the loaders, list of the bootstrap loaders, the system is asking the user to input to which boot sector it want to continue, it just wish to continue. Windows 2000 Professional it want to enter, Red Hat Linux it want to enter, or the Solaris operating system it want to enter. Whichever the user want to enter, user can press the accordingly. Then the booting and ROM. What is the relation between booting and the ROM? The systems such as the cellular phones, the mobile phones, the PDAs and the game consoles store the entire operating system on the ROM. As the operating system in those in these systems, in these devices, the small devices, the operating system is very short. The very small operating system is there, so it takes very small memory. So the entire operating system can be stored on the ROM. It is done only for the, it can be done only for the small operating systems, and the simple supporting hardware is required for these systems, and the operation is very rugged. Then the changing bootstrap code would require changing ROM chips. With the ROM chips, if we are storing our BIOS on ROM chip, there is one problem, that is if we want to change the bootstrap code, it means we would require changing the ROM chips, or the EPROM chips are available today, that is erasable programmable ROM chips. But this erasing and reprogramming is not possible at the user end, this can only be done at the vendor side, at the manufacturer side. So the code execution in ROM is slower, it can be copied to the RAM for faster execution. As we know, the speed, the access time between the ROM and RAM as compared is faster. Which one is faster? That is, RAM is popular for faster execution, for faster access time. ROM is slower as compared to the RAM memory. So the code execution, whenever the operating system is loaded, the code execution can be transferred from the, can be copied from the ROM to the RAM, so that the system can perform better than the, if the operating system is in ROM only. Then the BIOS configuration. Set up program interfaces. How we can configure the BIOS? Program interfaces we can set up. First of all, hit a particular key or key combination at a right time to enter the BIOS setup utility. Whenever we are starting our system, there are a number of options to enter this BIOS setup. F8, Del we can press. The message is there at the screen. According to that, we are to press that particular key or key combination at the right time to enter the BIOS setup utility. Now BIOS setup screen will be there like this. If we are entered in this, then the typical key control. Incorrect settings of BIOS may lead to the system halt. Whenever you want to set up your, configure your BIOS, the settings very much matter for that. If there are any settings incorrect, that may lead to your system halt. So be careful when you are setting your BIOS, configuring your BIOS. Quit the setup without changing, without saving changes if we are not sure about the change setting. Sometimes we got changed our settings, and at the end of the setting, if we are not sure that they are okay with us, then we can quit the setup without saving changes. That is the safe method for BIOS. Then the boot sequence, in which sequence the boot sector, in which sequence the control जो है आपका ऑपरेटिंग सिस्टम आपको कहाँ से ढूंढना है, किस सीक्वेंस में आपको मेमोरी से उठाना है. The boot sequence is there. The control the order in which the BIOS looks for an operating system on startup. किस मेमोरी के ऊपर आपको ऑपरेटिंग सिस्टम सबसे पहले चेक कराना है, that is called the boot sequence. So the usual sequence जो है, that is your floppy disk, hard disk and then CD-ROM. You can change this sequence according to your, if you are to load your system with new operating system, you want to install your new operating system, then the CD-ROM can be the first in sequence. If you have already installed your operating system, you can change the hard disk as the first in your sequence. Then the performance tunings through the BIOS settings. BIOS settings are responsible for how the chipset is controlled. Chipset, as the chipset is the key to overall system performance. Chipset is what? That is the combination of the north bridge as well as the south bridge. Chipset is the key to the overall system performance. So, the BIOS parameters, various BIOS parameters that can be set up during the configuration. We can choose the optimal bus speed settings. We can enable the CPU's internal cache. We can external cache memory can be set up. We can enable the system BIOS shadowing, and the quick power on self test can be enabled, and the BIOS can be updated during the configuration of the BIOS. Then the second hardware component, that is CMOS, complementary metal oxide semiconductor chip, that stores your BIOS also. Separate chip from, this is a separate chip from ROM BIOS. This is volatile, keep alive by the battery only. It can be keep alive by the battery only. The data stored on this chip will be lost when your power is off. It stores only the changeable data. The permanent data cannot be stored on this chip, as this is volatile. The data will be lost when your power is off. So, it stores only the changeable data. It not stores the programs. The programs are stored only on the BIOS. It acts as a clock to keep the data current. The clock settings are dependent on the CMOS battery. It is customizable via setup program, and it is often on the south bridge. These are the various comparison parameters. BIOS store your programs and CMOS store your data. BIOS is non-volatile, that is the contents will stay same after the power off also. The CMOS is volatile, it kept alive with the battery only. The data will be lost, data will be changed when the power is off. Can be changed by flashing only. Then the CMOS can be changed by a CMOS setup only during the by the software hand. The data in the BIOS, the BIOS size through the flash ROM is much bigger. The ROM ka jo size hai, that is very much bigger, but the 64 kilobytes of the programs can be stored, and the chip size is typically 64K, but the data can be, we can store 120K, 128 kilobytes. This is often a separate chip, and CMOS is often on the south bridge. This is the main menu. This is the main menu. Access to through the CMOS setup. CMOS settings can be configured. This is the configuration of CMOS battery chip now. This is the main menu. Through this main menu, we can access all of the sub menus. The first is, as I can say, soft menu setup. Then the standard CMOS features, advanced BIOS features, advanced chipset features, and many more. One by one I have covered here. Standard CMOS features. First one, in this the clock, the hard drives and the floppy drives can be configured according to our requirement. The first of all, like the date and time can be changed. Generally we start our date in which currently we are in the time of the today. The base memory and the extended memory. The memory's length can be decided over here. The drive names can be changed over here. The number of floppy drives, how much you want to enable, how much you want to disable. This is soft menu setup. In this, normally the setting jo hai, that is set to default or automatic for all of the settings. Generally, if we don't know what is to say, what kind of input we can give this for any particular setting, set it as a default, the system will work out. Then the in the advanced feature sub menu, that there is a post and boot order. We can check our quick on power on self test, it can be enabled or disabled. Then the boot order, in which order the boot priority is to be continued. We can press enter here, and then the order can be specified here. Power management, we can by this power management sub menu, we can enable or disable the power saving features. We can enable or disable the power saving features. This is the important setting, that is set password. By this setting, we can lock the access to CMOS settings. For any non-technical person, for any other user which is not familiar with us, which is not a well-wisher of our system or ours, from those persons we can lock our CMOS settings by our setting our personal password over here. Till now I have covered the BIOS settings and the CMOS settings. What is BIOS, what is CMOS. Now the next topic is what is interrupt, or we can say what is exception. Interrupt, the meaning in Punjabi, that is rukawat. How this interrupt is occurring and how this interrupt can be handled. All these I will cover through this topic. The first of all, like this main program is executing. We are doing something in this program. Suppose we are browsing or anything